Hello, friends of software entertainment, and welcome to part two, building agentic AI in PHP with Neuron AI, spectacular framework. And welcome again, the maintainer Valerio.
Hi, Roland, and thank you for having me again. It's a pleasure to share this kind of moving forward into the development opportunity that PHP developers now have with Neuron AI.
Yes. So, what was your maybe last thing where you used it, or what special kind of handling? What was your most pleasure in the last time to use your own framework, maybe in a project?
Yeah, we are working also with other companies that are adopting the framework to create their use cases, and so we are creating a lot of can I say, the prototype, for helping companies to create prototypes that they can show to their customers. So we are in this kind of activities. And the most important use cases that I think is driving value for software houses to sell these new developments to their customers is really automate human tasks. It could be just like data entry. It's aggressively addressed from software houses that, thanks to AI agents, that they build custom AI agent, they are trying to completely automate data extractions from documents and then send these data to downstream systems. These kind of activities, parsing documents, is really under development. And we'll see. It's Neuron is just 1 year old project, so really young, really promising. So we are exploring a lot of direction, but we are moving forward with developers' use cases. They come to us with their ideas, and we just try to move forward and implement solutions based on real development needs.
I think the most benefit is that you do not take AI to fix all your problems or to analyze all your data or to make this, the AI cloud code will fix it or whatever. The thing is that an AI can use this kind of PHP tools, what also can be your own methods to handle things with data. And so the data are really good in calculating and things because you can bring in the business logic bulletproofed for results for the AI. Is this a target of the
Yeah,
framework?
absolutely, because this is one of the most important topic that also our customers or partners we are working with, they really take care of this aspect. So AI, it's not a way to delegate some task and forget what the AI is doing. It's just implementing tools like agents that can collaborate, that empowers human operators. And this is depends mostly by this ability of these AI agents to perform the tasks under an ongoing conversation where human can constantly ask new questions, provide new data, feedback, etc. So this kind of interaction is what it's the center of this new implementation. These agentic applications need to be built on top of these cooperation like operational design, just not click a button and the AI does everything. It doesn't work that way.
So, what would we do today? What will we see today?
Yeah, in the previous video, we had the time to look inside the tool systems, the ability that developers have with the framework to give the AI model these kind of tools that are basically local PHP functions that the model can execute. And this really helps developers to allow the model to ask the execution of local tasks that can be ask data from an external systems, or perform some task on the database, put some data into your context. And this is just really the first building blocks of these entities. But now today, I just would break the wall of the memory systems, that the ability of these agents, these entities, to remember what is going on into the conversation, into the task that you are trying to delegate to the agent. So Neuron has very good, I can say, because it was one of the most important modules of the framework that was really appreciated in since the first version of the framework. I got a lot of very positive feedback about this particular implementation. But now in the version 3, it's really, really refined. So maybe we can, jump into the code so I can show directly how it works.
Yes, please. Do it, and I will share your screen.
Yeah. Most of the time, just seeing it working is the best learning experience. So I prepared this very little code example where I created this kind of very simple agent in Neuron AI. So I also recommend all the viewers to jump on on our first conversation, because maybe this kind of syntax, how to create an agent, we already saw in that
in the last video. Yes,
how to do this.
I like the style very much. Yes, I like it very much.
Yeah, it's not very, very expressive. We try always to keep things, also the name or the methods are very clear, because I think the developer experience is one of the most important part here. And not only for human, but also for the coding agents. We will see eventually later how Neuron, so it's coding agent friendly too. So I just created a simple agent, demo agent, that extend the basic agent class. I attached a provider. Here you can provide, all the providers supported by Neuron framework. There are a lot. You can see them in the documentation. And I have this environment file with all the keys that I need to make things works. And I attached just a toolkit. In Neuron exists this concept of toolkits that is basically a collection of tools toward a specific use case. So instead of attaching all these tools one by another manually,
then you can group it by...
can create a package,
yes.
I can say, and attach the entire toolkit in one line to the agent. So in this script, I just implemented a simple, it's a loop where I get the input from the console and provide the prompt to the agent. Here is where I submit the message to the agent and then print the response just to see how it works. So it's the example 3. It should show up the prompt. So I see, do you know who I am? Just a couple of seconds, the agent should respond. I don't have any information. Clearly, the agent, the model, doesn't know anything about me. Okay, so I just provide my introduction. I'm Valerio, CTO of Neuron AI. Great, okay, nice to meet you, blah, blah, blah. So now I ask, do you remember who I am? Yes, I do. So now in the conversation, the model has all the information about, in this case, about me, but it could be the same with the task that maybe you are trying to ask the agent to perform.
And this works out of the box, yes?
Out of the box. As you saw in the agent, there is no expressive, I didn't declare any special components. The agent is this kind of memory built in. But if I run again the script and I ask, do you remember who I am? Again, the model don't have any memory of the previous conversation because by default, the agent uses an in-memory chat history. These components. So by default, the agent keep the memory of the ongoing conversation just in memory. So it's valid only for the current execution cycle. Okay, once the process stops working, basically this memory is lost because at the end of the day, it's just a simple array, PHP array. So once the execution cycle ends, PHP engine stop execution and this memory is lost. But in Neuron AI, we have a bunch of other options. This is the section of the documentation where you can learn a bit more deeply how it works. And you have a bunch of options. You can store the chat history in a file. This is basically an adapter pattern where you can create the interface to communicate and to store the context of the conversation into your specific persistent system. So it could be a database, or for Laravel, you have the instruction to extract the PDO connection to the database. We provide already the scripts to create the compatible table to make it works in your database. And also we created an explicit implementation using the Eloquent ORM, the Laravel native ORM, just to give you the shortcut implementation that you are ready to use, basically. So to give you a more realistic example, and now I'm going to use the file chat history. So we are going to store this context of the conversation into a file. So instead of in-memory chat history, I can attach the file chat history and just provide a directory where this component should store the conversation, the file. I think it should be, this is source. I want to go to the root project directory. And yeah, here it is. So we should see the new file stored here in the project, so we can explore what is stored into this file. Let me clear the console and run the example again. So do you remember who I am? Sorry. Oh, too few arguments. Okay, I need to give the key to the file. And this is important because this is a way, a demo, for example, because through this key, you can basically store different conversations in different files. Maybe you can store them for users. You know, you can have different conversation for different users. So this key is important to...
Or for the task, yes, that you have not everything in SuperBrain.
Otherwise, all users, you know, start the same conversation. With others. That's just an example. It's a way to group, you know, his chat history and keep them separate. So I run the example again. Do you remember my name? And the agent obviously don't know anything. I'm Valerio. Nice to meet you. And now, do you remember my name again? And now he remembers who I am. And in the project directory, we now have these Neuron demo chat files.
Mm-hmm.
And at the end of the day, I want to format it a little better. It's basically, here it is, a list of JSON objects that are basically the message that we exchange, that we are, you know, back and forth from me to do. Yeah, do you remember my name? This was my first question. And yeah, this is the first response of the agent. I make it a little bigger. This is the response of the agent. And then I'd be happy to use. This is a bunch of other information, metadata about the token consumption of the chat. Then there is another message by me, and then the response for the agent. So at the end of the day, this chat history is just like a way to store all the messages that is going back and forth the agent, and a couple of metadata that allows, you know, the framework and the agent to store all the related information that need this component to make it work, basically. And what is really interesting of this component is the ability to adapt the storage of these contexts based on the maximum context window supported by the underlying model. Because I think most of you know that the LLM has this kind of really hard limit, that is the maximum amount of information that they can process on each turn of the conversation. And this is measured in tokens, basically. So this is the unit of information that the model use to process the data we are sending to them. And in the component, in the chat history component of Neuron AI, you can explicitly tell the component how much context you want to keep at maximum in the history, and the chat history component will automatically cut all the messages that goes outside of this context window to avoid basically fatal error on when you try to send a new message on the provider API. And what is really happened behind the scene, I have this little slide. I hope it can, make this concept clear, because this is like an example of what we really do just before. So we have a bunch of user messages and the response by the model that is called an assistant message. So we have all these pairs, user assistant, user assistant, user assistant, and so on. And over time, all these previous messages stored into the chat history basically grow and make bigger the context that we send every time to the LLM. At a certain point, if the underlying model has a limit of 100K tokens as maximum context window that the model can deal with, this conversation at a certain point can exceed this maximum amount of tokens. And in that case, Neuron chat history component automatically cut from the context from the chat history the older messages to always keep the current chat history in the current memory inside these maximum context window limitation. And this is really, really helpful, because obviously the messages that you cut, the older message, are hard context loss. I don't know if it's clear.
Yes, I understand. I'm thinking about different kind of things, but for in your experience, 100,000 tokens, is this a good value, or what do you think you need more or less, or you cannot?
Yeah, so modern providers, the latest model that it's going releasing, that they are going to release, they support even more big context window. General, they are now around 200K, is quite supported by almost every model. But the problem, it's not really the hard limit in terms of the maximum context window, because as many developers know, also using coding agents in our own daily work,
Yes.
the model start to really degrade, if I can say, their reliability on the task and the response they provide a lot before this hard limit. It's called context rot, that it's the decreasing performance of the model while the context that you provide to the model grow. And I think every model hit a reasonable performance on the 50% of their hard context window limit. So even if the model, support 200,000 tokens as a maximum context window, I really suggest to never go more
Over
than
30,000.
50%, maybe 60, 70%, but 70% you have
15.
really,
I said 15. So 50, okay.
yeah, 50%. Yeah, so 100K tokens. Maybe you can go a little farther to 120, but the performance of the model at this point are slowing down very, 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 very fast. So
there is
it's
no
more,
not some kind of summary function that will check this chat messages and see what are the learnings of the chat, and then will cut all the things and say, hey, this is real memory.
yeah, very good point, because there are a lot of strategies, that you can use, and also the products that we are using, like Coding Agent, because they are really a very good example of the tool that we use as developers, so that we can learn a lot from what Neuron AI, the component that Neuron AI allows you to use, and the real effect they have behind the scene. Using this tool, we can really have a real-time example of what's happened behind the scene. And the summarization, this kind of tool have this compact feature that
Yes.
when the model reach the context window reach certain percentage of the hard limit supported by the model, they automatically start this kind of compaction. And in Neuron AI, you have ready-to-use components for this. That is the context summarization middleware. It's a little bit advanced topic, because it requires you to understand how the middleware system of Neuron works. But in terms of the snippet, the code snippet, this is I think this speaks for itself. You have this component, and obviously to be able to perform this summarization of the chat history that you already have in place, you need to to use another provider. You need to use a model to perform this summarization. So you need to provide to this component the same model that it's your agent it's using, or maybe sometimes developers prefer to use a more cheaper model for this task, because maybe to power the agent you use the best in class model, but for this tiny internal task maybe you can choose something cheaper. So you have this flexibility with Neuron AI, because as I show in this slide, the messages that will be removed from the chat history, it's an hard context loss. These messages are lost, so you are losing context in the ongoing from the information. The model is losing information that maybe you provided in the first messages of the chat. So it's a hard loss. Summarization allows you, to have a soft loss, if I can say. They just maybe trying to keep the most important information from the entire chat history and exchange all these list of messages with just one message, maybe a little bigger, just not tiny message, because it's a summary of everything that is going on in the conversation, but you can start basically the conversation from scratch. I also have an example, I think, of this process. Okay, here it is, summarization. Yeah, but I don't know how it can be clear, because at a certain point I use the context management. Okay, this is the same, basically the exact same, code snippet that it's in the documentation. And the beauty of this system is that since the chat history component of Neuron AI works with tokens, unit of measure, you can really create very refined configurations. Other framework allows you to set a limit on the number of messages that you want to keep in chat history. But, it's there is no real connection between the number of messages and the number of tokens. You can have 10 messages that take, 100K tokens, or, it's
you have one message. You have one message who can take 170,000 tokens.
Yeah, why not? It's you start attaching files, sending a lot of text, an example of a book. I don't know. It's a single message, but it consumes a lot of tokens. So Neuron, instead, we try to work. It wasn't easy at all, but we keep this connection with the same unit of measure used by the model, so you can really create very refined configurations. That's the topic. So you can summarize. This is also a built-in component of the framework, so you don't have you have to spend more time to learn basically how this stuff works. And here in the documentation, there are a lot of information, because our algorithm, the algorithm that we implemented in the last version of the framework, always try to minimize the context loss. Because let me give some insight on this, because it could be very interesting also to learn how this agentic system works behind the scene. Because the conversation, it's not just about my message, the user prompt that I send to the model, and the response of the assistant message. As we showed in the previous conversation we had, we spent some time explaining the tool system. So in the middle of these user assistant messages, you can have also the tool call and tool result pairs. Because when you send a prompt to the user, maybe the assistant, instead of coming to you with a concrete answer, the assistant responds with a tool call. It asks to run a tool, and your next user message, it's basically the framework that provides the model with the tool result. And then eventually the model provide you the final answer. Tool call pairs, tool call and tool result, can be part of this conversation, and you can't break these pair messages. So when you delete something from the conversation, the chat history component should really take care of what is going to be deleted, because there are some hard rules that the provider and the models expect that should be maintained to have a valid conversation format. A conversation need to start with the user message. So you can't delete a couple of messages from the chat history and maybe your chat history start with an assistant message. You will receive a fatal error from the model APIs. And the same way with the tool call and tool result pair. You can't break these pairs messages. Otherwise, you get a fatal error on the APIs. So the chat history look also into the structure of these pair, messages pairs, basically. So this example that I created in this slide, it's not, it's not casual. User assistant, you have to delete the pairs from the chat history. You can break the conversation at any point because this breaks the APIs, basically.
Okay.
So it does basically everything automatically, and this is really something that developers really appreciated since the beginning. And to avoid, any strange behaviors from the communication between the agent and the underlying model, we recommend to keep the maximum context window in your chat history, slightly lower the hard limit of the underlying model, maybe 5%, it's enough. But as I said you before, it's really no one recommend to use the entire context window of the models because the performance, are not good even yet at the 50% or 60%. So you will never should, take the maximum context window supported by the model as a valid reference. You should keep this limit much lower anyway. So hope this is interesting. I came back to you with the video. Okay. So eventually, I would like to show you another feature of the frame, if you have time,
Yeah, sure. It's spectacular. I can listen the whole day for it.
Thank you. I let you guide me, if I'm going too far, because there is another very powerful feature of Neuron AI that developers are interested in. They're using a lot because it's really about automation, and this is it's the ability of the framework to extract structured output from the context the agent have. And the context, by the way, is the chat history that it's inside the agent. So you can provide with your message or with tool call, the agent just grab context. This is the way I think it's the best way to think about agent interaction. Even when the agent start calling tool, it's because the agent need more context to answer or to your question or to perform the task you are demanding. So the structured output feature is the ability of the agent to take some input or maybe the entire conversation and generate strictly structured output that you can use to represent the data in some structured way, so you can maybe use these data to integrate with downstream system, with other external APIs, or for some data entry task. You have, because I think everyone knows that AI models are very undeterministic entities. So we send them a prompt and they respond with a bunch of text. And maybe sending the same prompt, the same question, they can even answer in completely different, with completely different content. So the problem at a certain point working with these models was, how can I get data from the use the cognitive ability of the AI models, but getting structured data from this interaction. So this is, the two-way of look at this problem, because AI models provide, cognitive capabilities. They can adapt to changing context, but as developers, we are usual to work with the API requirement. We have to send data to an external system, and we need this data to be formatted in very specific ways. So the problem was to how make these two words connect each other. And the solution we created in Neuron AI was this structured output module, where you can declare the output data that you want to grab from the agent interaction as PHP structured class.
Oh.
So in this example, as you can say, I just created a person class. This is a plain PHP object with a couple of properties. In this case, name and preference. But this is very PHP poor code. And then I attach this. I can make it a little bigger.
It's okay.
Okay. Yeah, I think you can see better. These PHP attributes called schema property. It comes from the Neuron AI structured output module. And this is, the way you can provide information to the model about what this property is about, to help the model understand why it should be fill this property with some data. What kind of data you expect this property to contain? Okay, so the model can take the right decision when he decide to put data inside this property. So the schema property attribute is just the tool that you can use to tell the model what you want to do with this property class. And I have an example. Let me open directly the example I'm planning. This is really, I think this is really interesting because I created, in the same way it's in the documentation. I create this person PHP class with a bunch of attribute, first name, last name that is not required. So you can also tell the model what properties are strictly required and maybe some others not. This is the age. And this is another property that it's declared as a type. It's a sub-object. So you can also nest object into object.
Wow.
Okay, so this is, let me format this in the same way. Okay, so this is the way you can use, once you have basically created this PHP class that represent the data that you want the model to respond with. You can use, instead of in the previous example, we use the stream method, to get the real-time streaming response of the model. In this case, we need to use a different method to activate, this module of neuron. It's the structured method, and you need to pass the fully qualified class string of the structured class that you want the model to respond with, along with the prompt we want to send to the model. In this case, I'm telling the model, I'm Valerio, I was born in September 1982, and I love pizza. It's basically a way to give the model all the information to fill the first name. I told the model when I was born, okay, to understand the age, and then also I tell the model I love pizza, so some kind of preference, if I can say. So let me run this example. PHP, probably this is the for example, and go. So running the script, I directly send the prompt to the model and waiting for the response. What is going on? Let me check out the error. The response also contain
maybe it's a formatting.
Yeah, I wasn't able to extract. Maybe I can use Opus 4.6. Let me try again. There's some error. Let me check if there are some updates on the framework side. Nothing. So it's we can debug real time. So I should have the structured method so we can see where the where the agent breaks. The struct of node 161, because I think it's trying to validate. Maybe it's the validation that I added to the class, to the person class. I added some validate greater than equal. I can remove these validation rules to make it a little more flexible, and we'll see. Oh, here it is. It was some too strictly requirement. And what we see here as output, it's basically built with this simple string. And this is, I think, the cool thing of this.
This is super cool.
Because the response that you get from the agent, it's a real instance of this class, of the structured output class, with data filled inside.
This is super cool.
And this is cool because once you now have a real PHP object, you can also add more methods to it. For example, you can add a method that can, you can perform, some check if the current set of data is really valid for your use case, because all these stuff are basically ignored by the agent.
And then you can also have some kind of form assistant.
Absolutely.
This is very good. Spectacular.
It's basically, a representation of a
highlight
data
of my
collection.
Day.
Yeah. Yeah, the ability to work with real PHP class, real PHP object, I think it's the cool part.
To do. So maybe this is a good point for a question here from the chat. What is the benefit of middleware workflow management instead of event listener one? This is a question from a Symfony developer.
Oh, okay, great. So in Neuron AI, there are two main ways to hook into the system. And these two ways are basically the middleware system. If I can say, it should be a really... this is basically how middleware are designed to work. So you can attach middleware into an agent, or if you want to create a workflow completely from scratch, you can basically attach middleware to nodes. You can wrap before the execution of a node and after the execution of a node. So you can really wrap basically the node execution. And the example I showed before with the summarization middleware, I create the middleware, and then I attach the middleware to the three main nodes that are designed in Neuron Agent to provide answer to the outside of your application. It's a chat node, streaming node, and structured output node. So you can basically wrap node execution with middleware, but this is not really designed for, this is just to condition how the workflow or the agent should behave, okay? Because middleware take the context, the execution context of the agent or the workflow. So the node, the instance of the node that's being executed, the event that is going into the node or outside the node, and the real workflow state. So with the middleware, you can really change how the future nodes should behave, because you can really intervene into the real context execution of the agent or a workflow in general. Instead, if you just want to monitor, let me get, here is the monitoring and debugging. If you want to just monitor what's happening inside the agent or inside a workflow, more in general, you can use observers. And this is not, this is a component that it's basically what I want to know that it's happening from inside the system, but without the ability to really, intervene, okay, to change the behavior of what's going on behind the scene. This is what I want to learn from the system. Middleware is what I want to condition the agent to change its behavior based on the execution context. I hope.
Yeah, I think this answers the question. Yes, for me,
yeah.
It was a good answer.
And inside the framework, there is this log observer that it's basically, let me get here inside observability. You have this log observer that you can, take as an inspiration, to implement your observer interface. This is just an example that you can give to this observer a logger interface. It could be monolog, etc., and it just log all the events that happen inside the agent just for logging purpose. That's so this is what I want to learn from the system middleware. It's a way to take action proactively to condition how the agent should behave. Because yes, maybe there's details that cannot be really clear on a first look. Because in Neuron AI, we extend the agent class to create our own agent, okay? But the agent itself is a workflow.
Oh, okay.
That's the the layer we are building on top. So the workflow component architecture in Neuron AI is basically the foundation of all the framework. It powers all parts of the framework because allows you to create these composable architecture, if I can say. It can be a single node, it can be a multi-step node, and so the agent implementation in Neuron AI is just a workflow implementation. This is something that I goes only in on these.
There's so much features where they are so far in the future from all of us that you already have implemented it. So this is a spectacular framework here.
Yeah, something really cool.
Also, just going through this documentation will be a lot of inspiration.
Yeah, just to show you what you can do. We are going a bit far okay, with this demo, but it's okay to open the mind of developers. And one of the most interesting features that the workflow architecture enable is the human in the loop. We always talk about this need that we have to keep the human in the process of collaborating with the agent. But implementing this feature is something really, really, it's not a very straightforward feature to implement in any framework. And Neuron AI, it's one of those that support this pattern. And it depends by how the workflow architecture was built. I just want to give you an example of this, of what this means, basically. So in Neuron, you already have, let me pick the documentation. In the agent section, you have the middleware section. These are a couple of middleware that we already created at the built-in, that you can just start using for these very common use cases. And one of these common use cases is the tool approval system. When an agent tries to run a tool, maybe you want to stop the execution and ask the user if you want that this tool can be executed. Really, it's the same way the coding agent constantly asks us the permission when it wants to run a bash command, for example, just to give you the chance to take a look if the action could be disruptive. This is just
yes.
an insight. And so I attached this built-in middleware to the tool node of our agent. And I created just a couple of tools that are fake tools, file delete tools, just to simulate, this kind of action as a return.
I also was thinking about deletion or whatever.
Yeah, just to simulate this kind of action, but I don't perform any task, just return a string, just to, to have an example. And I have my interactive console, so I can run PHP public human in the loop example. PHP. Okay, so I ask delete the cover.png file, just to induce the model to call the file delete tool, for example. Okay, the agent think a bit this action and comes to me with asking permission. This is activated by this middleware. Okay, when I don't pass any, because this middleware accept a list of tools. Okay, if I don't give specific tools, it acts for all tools. Okay. So I can approve or deny. Imagine I deny this action. This is just, an implementation of this.
So now it will also ask to read. Yes, should I read the file?
Yeah, absolutely. Yeah, I can tell them, and I denied the operation, and it recognized. It looked like the deletion was rejected. Okay, so it doesn't perform the action. So another the PHP. Let me clear the console. If I ask read the cover.png file, it should ask permission. Again, Okay, I can eventually give it the permission to do. And okay, was read but return no content because there was some error. Okay, I tried to file get content of non-existing file, but the action was performed by the agent. So now what I want to simulate, it's a quite real world example where I have a buy ticket tool where I want to give the agent the ability to perform a checkout session eventually, okay? And I give the agent explicitly, okay, I declare that I want tool approval activated. So let me also uncomment this. So we have all the tools, but I want tool approval only in case the agent call the buy ticket tool. So if I run the agent, I ask delete the cover.png file, and it should perform the action without any permission because it's not included into the tool approval restriction, okay? But now, if I ask buy
A ticket.
2 tickets for the concert, okay, it give me a follow-up question. So we should have more. We need to be more, precise to induce the model to call directly the tool. So buy 2 tickets for the concert at $100 each. And now it should be able all the information to call the tool. And in this case, I got the permission, and the agent, also asked me with the information he's trying to use to buy the tickets at the end of the day. So I eventually deny the call. But with Neuron AI, you can go a bit further on this implementation because along with the tools that you want to, to check for human approval, you can also associate a callback function that gets the input arguments the model is using to call the tool, so you can enforce tool approval based on a completely custom logic. In this case, I'm telling the agent to ask for approval only if the amount of the ticket to buy the tickets exceeds $100. Okay? Let me run the example. I ask this.
This is spectacular, yes.
Buy 2 tickets, tickets for the concert for, $102 each. The agent start to perform the task. Undefined array key amount, something was wrong in calling the tools. Okay, because it's not amount, it's called price. It was an error in my logic here. So clear the input, go with the agent, buy 2 tickets for $2. Now the agent try probably to call the tool. The price exceeds $100 and it asks for permission. Okay, maybe I accept these two call, and at the end of the day, it's done. Now I want to ask for the opposite. So buy 2 tickets for the concert for $99, just slightly, lower
Yes.
than $100, and it should go without any, any permission. And
Wow.
it's the case. So you can really customize this kind of behavior inside this callback. It's a good place where you also can integrate, permission system that you have in your application, authentication. There's a lot of integration points that you can use this architecture. Okay, that's just to open the door.
Wow, this is amazing. So many features.
Yeah. Yeah, maybe we are going, back and forth along the frameworks. Basically, I think you can imagine Neuron as a toolkit that you can start with your very simple use case, but with aware that when you start going forward with your use case, Neuron probably already have what you will need, to scale up your implementation, your use case, and there are a lot of very cool stuff that I'm working on right now for future releases, but we'll see.
Can we have a hint? What are you developing for the future?
Oh yeah, because at the end of the day, it's open source, and yeah, one of the most important bottlenecks is a very advanced use case, because once you start using the agent implementation, it's a built-in implementation of the workflow component, so it's just our proposal, because developers then can start take inspiration maybe from the agent implementation we created and create their own agentic systems, that it's completely customized, because you have the workflow behind the scenes. So you can add new nodes, you can use, for example, this kind of loop node. It's the way we implemented the tool loop into the agent, where the workflow agent just loop around the tool node until the underlying model stop asking for tool executions. And this is the most important, bottleneck I saw in this initial architecture, because at a certain point you can have a node into your workflow that should take a decision to, going into a branch or going into another branch of the workflow to perform 2 different tasks. But my question was, what if we want to run these 2 branches of the workflow in parallel? That was really, maybe I was curious if it was possible, to create this kind of parallelization, because maybe in one branch you can use the structured output feature, to perform data extraction from a document, and in another branch you can instead perform the store the document into a vector store, for example, for retrieval augmented generation task later on. But you need the opportunity is to perform these two tasks in parallel. That was really the idea I want to explore. And I came out with this kind of, I think I have an example if you want to see it in action. It should be in this other demo project. Here it is. In the newer version of Neuron, it's not released yet. Okay, I'm working on it, but it's already working. So in my private development, you can start the execution of multiple branches in the workflow in parallel, because now the execution logic of the workflow, it's not hard-coded into the workflow itself, but I extracted this logic into a component called workflow executor. So you can now implement custom execution logic for your workflow. And I started with this idea of async execution, like it was, Node.js application.
Yes.
Okay. So if I run, should I able to run? Okay, I have this example. I just run this workflow into the node. I just have some delay, just to simulate the task as some kind of task performed into the nodes. And if I go, let me clear see, I have to go into this project. And I should be able to run public async PHP. So this script is just run this example where it print some kind of
different runtime. Yes.
Yeah, but with the way we can really see this in action is on the inspector dashboard, where you can see how the node B1 and node A1, they basically start just a little bit one after another, but they are performed concurrently. These three tasks are performed concurrently. So this is something that I think
will give a big push, yes.
Yeah, very, very interesting, because you can create very scalable agentic system able to perform multiple tasks in parallel, and then join the output, the final output, into a single final response. So this is really it's working, but it's under development, so I need to really refine and some edge cases, because I need to explore more deeply the possible side effects of this parallel execution, and we are working on it.
Yes, so.
And by the way, during our demos, this is all the code that we executed in the console. Today. You can use exactly the inspector dashboard to really look inside everything happens into the agent. This is very part, the professional part of our ecosystem, where we provide this kind of observability, this monitoring tool to hook inside the agent. You can see this is the tool approval middleware that was executed before with all the prompts, the tools that are running behind the scene. You can inspect the tool call, where you can see all the parameters that were used to execute the tool and the final output that the tool is behind to return back to the model. And it's very, very hookable. You can group these events in a way that you can, even in big agentic runs, you have this ability to explore the task. If you want to focus, for example, only on tool call, you can filter the list of tasks just to quickly find what you are looking for. Token consumption, by the way, it's completely automatically by the system, so you have really a lot of stuff in place you can play with.
Very good. This was a very nice session. I got so much technical inspiration, and I'm thinking about use cases. For what can I use this stuff? But it's amazing how many features are implemented and how is this behind my own Cosmos. Yes. So I'm totally smashed. Yes.
Thank you, Roland. I hope that developers looking for this conversation.
Yeah, I think this kind of format what you have here, when you're presenting things, you have this performance, how you speak, and that anybody understand it. This is amazing.
Yeah.
So normally developers, when they are fitted in their topics, they go super fast. Like I can also do this super fast, and everybody say, "Hey, this was too much step." But for me, I understand anything, and yes, exactly what happened, what developers need, what are the questions from the community to implement. And I think this is also a big part for the open source community, a big advantage that you get this feedback directly from people who try this. And so that there are other people out of in the world that needs the same features.
Yeah, this is what is really driving, my work in exploring the feature of the framework, the implementation. And I really invite everyone is looking for this conversation to, open issues on the repository or just post something on the discussion section. That it's a place where we can maybe spark some conversation without really an issue behind the topic. Just you can post questions, doubt, if you want to go deeper into some aspects of the framework, or you have a use case that you don't know really how to to manage. You can ask the community on the discussion section, open a PR if you are confident to work with the code. Also very open for pull requests. But it's a collaborative environment. We are in the open source camp now with Neuron in a big way. And feedback, it's what really drives this project forward.
So give feedback here in this comments under the video and on the GitHub project. Give it stars, give it likes, and
sure.
Open pull requests, sure, and help also to grow this fantastic AI framework that anybody knows it. 1 year old, and it's maybe a bit under the radar, this is a spectacular project, and now every time in the world coming out new open source projects for Claude with 50,000 stars and whatever. There is there's
really
a big trouble in the open source GitHub community. So this is not a little project, but everything beside of OpenClaw and whatever is little, and so gives them a few lightning in this spectacular open source universe.
Yeah, there's no reason anymore to look, at Python stuff or, as PHP developers to force.
No, we are back on track. With Valerio, we are back on track.
You are completely fine with. I know what I know is the Neuron architecture, and I know that is ready for basically quite any possible use case. And maybe the time that your use case grows so much that it push the Neuron capability under the limit, we already have implemented the new solution in along the way, like the parallel branch execution in the workflow, very advanced stuff. So it's moving forward.
Cool. Yeah, so I think for today we got a lot of inspiration and motivation. So
Roland, I want to thank you a lot for hosting me in this very open conversation. It was really a pleasure.
And I think we will see you when you say you release so much. It's just 1 year old and you implement so many features. And so I think we will see you here every few months with new features. And for me, it's amazing, and I learn a lot.
Yeah, thank you. By the way, it was 1 year old in public as open source project, but the framework itself has another 1 year, I think, that I worked on it behind the scene before releasing the framework as an open source project. So in terms of development effort, it's on 2 years old track now. But yeah, there are a lot of interesting things, I think, that are really into the framework. But by the way, developers tend also to use all these components, to blend all the stuff you build in a way that you can even imagine when you start building this stuff. It's a learning journey. It's always a learning journey.
So nice end words for us. So for the community, come back, like this video, share this video, give stars, give all hugs to Valerio, get in touch with him when you need any information and you do not want to make this public on GitHub. Just ping in on LinkedIn or email him or whatever. And so we will say we are out for today. Check the part 1 of the video, and here are also 2 videos for you. And so bye.
Bye.